Hey, everybody. Welcome back to your Dawn of Autonomy podcast. I'm Don Zoldai, your host, CEO of P3 Tech Consulting, and publisher at Autonomy Global. It's February, everybody, and we have changed the theme for this month to be all about AI and data. And we've got an incredible company that's sponsored this month and the CEO of that company on the show today, VICTUS Technologies. We've got Jesse Hamel on the show. Great to have you, Jesse.
Awesome, Don. Great to be here. Yeah, looking forward to the conversation.
Awesome, awesome. And we already have folks jumping in the chat, Jesse. We've got FireMech Tech Rob. He's out there from Monterey, California, saying good morning. Great to have you out there again, Rob. We are live. So chime in, everybody. Say hi, ask your questions, because we're going to be talking about contested environments, which has become the norm, I think, in the autonomy space, and what Victus is doing all about that. But before we get there, Jesse, for those that don't know you, can you give them a little bit of background about yourself first?
Yeah, thanks, Don. No, and again, thanks for this cool opportunity. So, kind of the basics of us are that it's actually I talk about my background first. So,
Yeah.
this informs kind of where I went with my kind of company. One is that I was in the Air Force for 20 years, so joined shortly after 9/11. Yep, yeah. Me and Don definitely. I don't know if we overlapped, but in the exact aim areas, but time for sure. So all active duty, joined shortly after 9/11, flew AC-130 gunships, did a bunch of research with Air Force Research Labs, published a paper on software-defined manufacturing, did some machine learning work, directed energy work, precision munitions, ended up eventually commanding Air Force Special Operations Drone Squadron, went to MIT, did some machine learning work, got a degree there, and then launched Victus out of there. And the problem set that I saw early on, this was in manned aviation and kind of traditional weapons from like the late 90s even, and it just
Yeah.
has grown since there, was
Yeah.
our reliance on GPS on almost
Yeah.
everything. And you kind of fast forward to where we are now, where drone warfare is kind of the primary means of how nations defend themselves in many cases. I think you make that argument. And
Yeah.
drones just being another kind of flying robot. So it's really the beginning of the age of robotics, of intelligent robotics, both the intelligence capabilities and our ability to scale robotic type devices from orbit all the way down to like the bottom of the ocean or humanoids in your house,
Yeah.
drones flying, all the same. Those things have really become, kind of like how they're dominating every area of human activity, and how we defend ourselves is the first thing. The problem being is that most of the autonomy is kind of an interesting question, and we can kind of dive into like what that means. I think people use that word a lot, and I'm not sure. I think a lot of times we talk past each other when we say the word autonomy, but you could say this at the very least: autonomy being we want a machine to be able to operate and do what the human needs it to do without
Yeah.
being controlled by the human like every step of the way.
Yeah.
So, and there's levels of this, right? What we found, I think we've seen this, this problem set of GPS reliance being kind of at the core of holding back autonomy, where
Yeah.
you had autonomy software that has an agentic component as an AI component that, if you think of kind of like a inverse triangle of Maslow's hierarchy of needs, where they will solve what am I doing, what does the human want me to do, where am I going,
Yeah.
but they forgot to solve the where am I.
Yeah.
So as soon as you put this robot in the real world where there's solar flares, there's clouds, there's water, there's GPS jamming, the
Yeah.
whole thing kind of crumbles.
Yeah.
And like Ukraine is like the perfect example of this. We
It
set
is.
out to invent a software to solve that.
Well, okay, there's a lot to unpack there. And by the way, thank you for your service to the United States Air Force. We have that in common, as you mentioned. And here's I love this picture of you. You got the stash going
Yeah,
on
thanks for that. Yeah.
back in the day. You know, so what you mentioned crewed aircraft, right? Like just normal planes and this GPS problem. Jesse, I remember, God, years ago, I was at Air Combat Command, and they're talking about red flag, and like we have to practice. We have to practice like all of our comms. Everything is dark. Like we've got no idea. And so like this problem of GPS denial, comms denial, all navigation denial, all of it has been a long-standing issue. And you're absolutely right. Now that we have so many more robots, let's just say, kind of entering the battle space in particular, but also on the commercial side too, right?
Yeah.
Whether it's ground, by sea, by land, by air, and of course space. How do you solve for that problem? So, unlike Jesse, I did not turn down my war college slot. I went. He turned it down, retired as a lieutenant colonel, and then went over to MIT on his own. So, good for you. Really cool that you spun Victus out of your not only your Air Force experiences and the problems that you saw, but then also your passion and kind of what you pursued there at MIT. So let's talk a little bit about it's funny you said the Maslow's hierarchy, and like where am I is like self-actualization, but like at the bottom of the pyramid now.
Yeah.
Um, so let's talk. Let's get a little more granular, right? Granular in terms of operational environments, because you ticked off a couple, but I think it's worth going a little bit deeper. People have heard about spoofing and jamming, and that's very common in electronic warfare, especially in Ukraine, but like globally. What are the other environments that are relevant, really, let's say, whether on the battlefield or just, delivering pizzas with a drone that impact GPS? In other words, if autonomy is hinged completely on GPS, how quickly it becomes unhinged in these particular conditions. Can you walk us through that a little bit
Yeah.
more kind of in detail?
Yeah, and it's actually it's an insightful way of thinking about it. Part of it is there's the environment, but it's also the commonality of how all of these systems work. So, in
Okay.
a very simple thing to think about is there's something called a Kalman filter algorithm. And unless you're a guidance navigation control nerd, you probably have never even heard of these things. The reality.
Okay.
It was invented back in the 60s. It is on every device that uses GPS, every single
Okay.
device. It works very well for saying, where am I? If you
Hmm.
either have human or computer vision of the ground, or if you can get a good signal up to medium Earth orbit from GPS.
Okay.
Because of that, when we declassified GPS back in the late 90s, we built everything around these kind of old math Kalman filters because it works, and we thought GPS would always be there. Fast forward to now, what you find is that it's very fragile, and we started learning this, and that applies to the environments that you're talking about. So whether it's a drone trying to deliver a pizza or Amazon Prime like to your front door instead
Yeah.
of the neighbor's front door, like down the way, or
Yeah.
a drone not able to navigate to its primary point, the reliance on GPS is and that particular Kalman filter algorithm that was never designed for this. It was built back in the 60s, again, never designed for that kind of use. That's actually
Yeah.
the crux of the problem. That then kind of that the underlies how that gets manifested in different environments.
Yeah.
That could be where that drone's going to deliver pizza to your front house, and there's a building in the way, and that stops the GPS signal.
Yeah.
Or like what I think what a lot of people see is like you go use Uber in New York right now. How often does it get your address right?
Oh my God,
Yeah,
Jesse, I was just in Las Vegas,
yeah,
and you're like in a casino parking lot, where they make you go to get your Lyft or Uber,
yeah,
and you just watch the little thing, and then like the car spinning around, and it
yeah,
says 7 minutes, your thing is 7 minutes away, then it's 4 minutes, now it's 8 minutes. It's like what
yeah,
is happening right now?
yeah.
But no, totally, when you're in that urban environment with buildings all around, for sure, that is
Because
a GPS denial like vacuum.
yeah, I was just
Yeah.
in New York. I was just in New York like 2 weeks ago, and got my Uber, didn't pay attention, just hit the address and just hit the button quick. And of
Yeah.
course, the driver's like, "Hey, you told me to go like 3 blocks down."
Right.
And then he came to pick me up and all. I was yeah, and yeah, New York is the worst on this. And then the driver's like the driver goes, yeah, dude, this like happens all the time. Like Uber
Yeah.
never works. It always puts the pin in the wrong way. One of the most jammed environments in the world
Yeah.
is our nation's capital. And lots of
Oh,
open
okay.
source published things you can see on this. There's all kinds of things going on and disturbances in that environment. You
That
just
makes
simply
sense.
can't rely. Yeah, and it does make right if you think about it, it makes sense. So there's there's all kinds of disturbances that affect our ability to use drones in these kind of environments. Another major one is if you're using a technology where the drone has to see the ground in order to know where it's at. There's a couple different technologies for that. One of them is called optical flow.
Mm-hmm.
And it actually works fairly well as long as it's clear day and you can see the ground. But as soon as you go over trees, as soon as you go over water, even like sand or snow, then it kind of the whole thing breaks down. So
Everything that you're talking about, except for the trees, maybe is reflective.
it's it's
Yeah,
reflective.
so the GPS
Exactly.
signals they're like bouncing off. They're bouncing off the reflection. I know, like in horticulture, as an example, GPS cannot go through greenhouses because it bounces off the
Right,
windows.
right. In this case, you're talking about, and there's two things. You have disturbance of the signal itself. By the time the GPS signal from medium Earth orbit comes down to like where a drone is or where you and I are on the ground, it has the effective power of like a light bulb. So it's very easy to disrupt. Very like it's not this strong signal. But the other thing being, if you're using a computer vision technique to try and say, well, I know I'm not getting my GPS, but I'm looking at the ground. This is actually common in a lot of drones. The problem being there, as soon as you get over any kind of reflective surface or an undefined kind of terrain, then it kind of fails away. So, to your point of like what kind of environments, if you need a drone to fly over water, then you've got a massive problem. If you need it to go to a highly urban environment, you got a massive problem. If you need to go to where there's like greenhouse, like any kind of weird reflective surface, even sand. And we've tested this a little bit.
Or underground, because we're not just talking
underground too.
drones, right? We're talking robots. Like, I've talked to so many drone companies that are in that mining space, right? And they had to figure out, okay, how do we navigate in a mine or in a tunnel or, in pipes, if the drone is small enough or the robot. So all of these environments are, oh, by the way, Greg Larson from Augusta Regional Airport is saying hello. So great to have you out there, Greg. Thanks for listening, buddy. So we have a little video. Is now a good time to roll that, Jesse?
Yeah, sure.
Okay, let's roll film. All right, awesome. I know that was a short one, but like I thought it was a really good kind of summary of what we've been talking about, this challenge that you saw and, the solution then you put together. So let's talk a little bit about that. And for those that don't know, and just to be direct about it, what exactly does VICTUS Technologies build?
Yeah, so pure software.
Okay.
And software where the kind of 30 seconds of it to enable what we like to call contested autonomy. So when you're in an environment where it's not perfect, it's not a lab, it's not a nice clean field where it's open. It's in this kind of where we live, right? We live like human activity, whether it's combat or whether it's other activities. Like we live in an environment where there's dust, there's haze, there's buildings in the way, solar flares get in the way. There's all kinds of things like this. So we have to operate, like that. So what we do, we built a software. That software models how that system works. Whatever that edge-based robotic system is, it models it. And then we put it in a simulator and we perform this kind of like machine learning. It's a very special machine learning and, not to use a bunch of buzzwords, but there's a data ontology that we use and a type of multi-state parameter machine learning we use. That's really our invention. And from there, we're able to model like how it should look when it moves based on gravity inputs. These gravity inputs are from something called accelerometers. The accelerometers are in everything. Your phone does step counts with accelerometers, not GPS. That's how it gets that step count. And it's getting that from gravity shifts. Like it knows how the gravity it literally detects that from a gyroscope and then an accelerometer. We've trained a model then to allow us to have a very precise location just based off of those inertial systems. The output, we train this then in a synthetic environment, and this is minutes to hours. This is not years or months or years. The output of that is what our provisional patent calls a synthetic GPS. That synthetic GPS then is deployed to the drone or other robotic system. And then it sits on that system. So this is actually important that there's no like connectivity required back to something else. It sits on
Okay.
that drone system, and then it passively receives that raw data, and it's received that raw data, and then it updates kind of a what we call a state estimator. That state estimator says, where am I? That's what it's doing. It's answering that question, where am I? We then monitor that calm and filter that we talked about, right? We talked about this earlier. So we monitor that calm and filter. If we have good GPS, then we do nothing. We just operate in the background. Because when GPS works, it's actually quite effective, right? You get a
Yeah.
location error of maybe a meter, and that's about it. What happens when you take GPS away is that that location error grows, and it's not linear. It grows like in a circle like this, and it grows quadratically. So it grows very, very fast.
Okay.
After about an hour, a drone will go from a location error of 1 meter to 1.5 kilometers when you remove GPS, jamming,
Okay.
or just remove it for whatever reason. That's it. So it's no longer usable, right? So
Yeah.
what we do then, when we detect that's happened, we then use our machine learning pre-trained state estimator, and we transmit that information to the Kalman filter. We do it in a way that the architecture, the software architecture, is expecting to see. That
Yeah.
then enables it to work in basically any software architecture. So you don't have to change it. So for those, anybody listening that's, into drones, if you're using PX4, ArduPilot, Pixhawk, some of these basic standards for the autopilot or the architecture, we work with all of those. There's no modifications or rollbacks or new APIs needed. So this is new kind of reference architecture that works with whatever hardware software condition that you have. And then it enables that device to operate without a GNSS signal from the GPS constellation. That's the kind of net, the net gain. So what you have, if you take a system that was going to have to work over in, was going to have to work in Ukraine, or was going to have to work in some other environment like that, and then you're operating that environment, all of a sudden doesn't work. The idea is that we take that drone, we put it through the system, and all of a sudden it can work in there with, no real changes to that system.
Wow. Because I mean, just that example, Jesse. I mean, I'm 100% even tracking everything going on over there. And, they've been using fiber optic cables, to not, for the communications, for the navigate, like for all of it, because of the extent of the, EW, the electronic warfare happening over there. And of course that has its own limitations. Are you saying with, and by the way, I know you're calling it synthetic GPS, but like as a product, VICTUS Technologies is your company. Like, do you have a name for the software, or is it just like the Victus, or like, what do you call
Yeah,
it?
yeah, we call it Phantom Nav in most of its applications. There's a couple other applications that we're using where, and this is a benefit of software, is you can be very kind of flexible with what a
Yeah.
customer use case is. So there's times where we have some customers that are using very specific centralized computer-based systems for their autonomy solutions.
Okay.
And we then integrate with that centralized system and then link that into the edge-based robotic system. That's
Mhm.
like a different part of the autonomy stack. I'll use that term. You hear that people talk about this a lot.
Yep.
So Phantom Nav is like a compartmentalized, you needed to work without GPS part of the autonomy stack. It's generalizable to other parts of the autonomy stack, depending on what the use case is.
Yeah.
There's nuances on, like, if you're flying a drone that's an FPV drone, so you got to pull the goggles
Yep.
on, and there's somebody that's actually on the sticks. There's a little
Yep.
way that that's done differently versus if you are using, there's an architecture called TAC or ATAC that many,
Yeah. Yeah. Yeah.
yep. If you're using,
Huge in public safety right
right,
now. They
yeah,
figured
they're
they looked
basically
at
all
the
using that.
military and said, "This is what we need over here."
Right,
Right?
right.
Yeah.
So if
The
you're
team
using,
awareness kit is what they call it, whereas it was the tactical awareness kit, right?
yeah,
For
yes,
yeah.
and it's all basically the same thing,
Exactly.
but it's on like a Google Pixel phone typically,
Yep.
or it's Android based. So if you're using that and your use case is, I want a human to be able to pull up an Android, Pixel phone, Google phone, for example, and I want to be able to influence 5 different drones
Hmm.
from 5 different drone manufacturers, and I want them to be able to operate without a reliance on GPS. Like, I don't want them to lose signal for GPS for a second, that all of a sudden just start wandering off.
Yeah.
That we solve that use case as well. That
Oh my
takes our
gosh.
that takes our core phantom nav machine learning, and then it applies it into that TAC architecture.
Okay, that's amazing. You know, I it's obvious, but I didn't think of it until you just said it. You know, this idea of, you know, swarms, and you know, we've seen just you know, a light show is a swarm, right?
Yeah, yeah,
And we've seen entire light shows like fall out of the sky onto people.
yeah.
Uh,
There's some videos of
because
this.
somebody messed with their signal.
Yes, yes. The reality, like, and this is not to be like this is not to black pill or anything like that, but like, if you went to one of these big ones in Dubai and brought a $50 GPS jammer with you,
Yeah,
you could bring that whole thing down. That's the reality. Like,
yeah.
because it's that fragile. Because what they're using, the only way a swarm works is if it has pinpoint location accuracy.
Oh, yeah. I mean, because it's
Like
a formation. Yeah,
each because otherwise the view doesn't work, right? Like each one
yeah,
has to be exactly in that constellation, or it won't look on the ground like what you're trying to make it look like.
right.
So we're that is typically, in fact, everyone that I'm aware of, every single drone company that is doing these light shows in the
Yeah.
US, and there's a lot of them in Dubai and similar, in China even,
Mhm.
they're
Mhm.
all using a type of GPS called RTK GPS, real-time kinematic GPS. It
Mhm.
requires a very strong signal, and then it has like an array of antennas. And
Yeah,
with those array of antennas, it's able to get, if you have a really good GPS signal, you're able to get, in some cases, like 3 centimeter accuracy with that. That's the only way those drone shows work.
yeah.
The minute you deny that GPS, like that whole thing literally comes down. And it's kind of terrifying if you think about like having 10,000 of them over your head,
Yeah.
especially if you think about, so that's just the drone show piece of it, but then think about a malign use of it in any kind of national security context, and it's
Oh, yeah.
basically the same thing.
Yeah. I think it was White House Down or something was like the opening scene,
Yeah,
right?
yeah,
With like
yeah.
Morgan Freeman on a
Right.
boat, like on the Potomac or something. And
Yeah.
what is it, Channing Tatum or whoever? Like they're, you know, jumping over the boat because the swarm's coming at them, you know, the president and all of that. So yeah, I think there was maybe a huge forest fire in China when that happened as a result of the drones coming down from that light show. So,
I
you know,
know
just
there's a Disney one where there's some people injured. Like
yeah.
Disney, I believe it was Disney Orlando,
You
actually.
know, when you think about it, Jesse, you know, so like let's just talk the commercial side for a second because I know, you know, your background is in defense and obviously super relevant to the battle space and what we're seeing out there. You know, but the commercial side has caught up. In fact, the defense right side, I just saw the 25 companies on the list for the gauntlet, you know, phase
Yeah.
one of
Yeah, we
drone
were just talking
dominance,
about
right?
this.
So
Yep.
this idea of the symbiosis between the commercial and the defense and like let's bring the commercial tech over here, but like when you think about you know, the commercial tech and where we are, you know, hopefully going to see a beyond visual line of sight rule coming soon, right? So you're operating beyond visual line of sight, and I
Oh
don't
yeah.
care what your
Yeah,
use
totally.
case is.
Yeah, totally design. If you're, yeah.
You know, it seems to me like this is a no brainer. Like you need something like, you know, phantom nav on board period dot. Like if I was an insurance company, I'd be like, what do you have on board when GPS goes away?
Yeah.
Because like that just, you know, other than just depending on how far out, you just can't return to home or just, you know, land in the cornfield is not ideal either, right? We've seen that even on active duty,
Yeah.
right? I mean, I was
Yeah.
at the Air Force Academy and, you know, they always have the Thunderbirds fly over at the graduations. And on this particular one a couple years ago, something happened. They landed in, you know, this Thunderbird like lands in a field. You know, it's just kind of like a nightmare
Yeah.
for everybody, you know,
Yeah.
and, you know, so that's not like as a business person where you want your business to be like, oh, where's my drone going to land? You know, when GPS goes away for whatever reason, or gets, you know, interfered with.
Yeah. Yeah.
So yeah, that's amazing.
There's an
So
interesting, there's just you mentioned now, there's one like interesting anecdote. And this is definitely where we're looking on the commercial side is even
yeah,
manned aviation. So
well, cool.
Airbus is routinely filing NOTAMs of GPS loss from London to New York,
Oh my
like over the last
gosh,
30 days. I know this for a fact that I have spoken with maintainers of Gulfstream G5s
Hmm.
flying ultra high net worth individuals around different locations. And I
Yeah.
know, for example, one of them that flies out from Tel Aviv, that the pilots have to pull the circuit breakers for GPS 1 and 2 and take off due regard visually. People in the
Oh
back
my
have no
God.
idea this is happening. And so to your point of like, this is a safety concern for like very broad application. I believe
Yeah.
it is. And I think it's something that we haven't really acknowledged. And we're kind of starting to really have to think about because of the proliferation of GPS jamming capability. Because
Yeah.
now you can build it into like a Raspberry Pi 5 and
Yeah.
have it done for a couple $100. You and I could go build one right now in like 2 hours.
Yeah. Holy schnikes. By the way, Seth Taylor's out there correcting me, and I appreciate that, Seth. It was Olympus Has Fallen. That was the movie
Oh.
reference from before. So, so hey, at least they're listening, right? But it was a good movie, and I just remember like, oh God, another movie where they're showing drones doing horrible things. Being from this industry. Uh, but yeah. So anyway, I squirreled for a second. Sorry about that. But look, you've been doing so much in this space in a very short period of time. Do you want to walk? We have a picture, and it's a picture of you in front of a Techstars. If we could pop this picture up. Tell us what we're looking at here, and tell us a little bit about this entrepreneurial journey, right? So we talked about your tech, but you've been gathering, you've been doing fundraising, you've been winning all kinds of awards. Tell us what this is, and then walk us a little bit through some of those milestones.
Yeah, yeah. So kind of became as we, invented this, worked through the problems, the problem, realizing that I think this is important for any like entrepreneur launching out is that you only launch out an entrepreneurial endeavor if another large company can't or won't solve the problem. So you kind of
Yeah,
start with that, and you're like, okay, that for multiple reasons, both can and won't, that just wasn't happening.
yeah,
So it's like, okay, it's worth like, the opportunity cost of saying no to all kinds of other corporate stuff, and then
yeah,
say, nope, I'm gonna go 0 to 1 and try to actually grow something here.
yeah,
So we kind of started that after doing well at like, very early companies aren't really papered, like napkin level, back in that napkin level kind of stuff at MIT in a hackathon. We did well at one of those. Got number two out of 68 in like a broader week-long thing in spring of 24. So it's like, all right, that was kind of validated my hypothesis. So like, let's try this.
yeah,
So then over that summer, it's kind of, it's very scrappy. Like, we're just getting a company together and we're building, we're filing for patent rights. We're building kind of like a basic shell of this. And then we applied to Techstars. Kind of, there's a couple big accelerators, YC Techstars. Techstars had a good one that kind of fit our timing and especially our digital approach. So we got in to the Techstars Miami, which is kind of like it works with a bit of the Techstars New York one. So that's the picture from getting into that. We got into that pretty early too, and that really helped that in that case, it did what Accelerator is supposed to do. It accelerated us. So
yeah,
there's an injection of cash, obviously is a resource that matters for any entrepreneur knows like that matters.
yeah,
So there's an injection of cash, but then that also really it helped us quickly kind of accelerate the business side and the
yeah,
tech side of both kind of companies. So, that was an interesting time. I was doing both MIT grad classes and Techstars at the same time, which was
wow,
intense.
yeah,
But I was able to take some of the degree program at MIT and use it for the entrepreneurial endeavors at the same time. There's a few kind of
yeah,
like credit bearing things we could do. So
yep,
that was those early days. We are just really building out the core tech, and then like any entrepreneur, you have to. It's all about finding who has Techstars uses this kind of um, rubric, if you will, to think about it, and they talk about levels of pain point, and I really like this.
yeah,
And there's level 1 all the way up to like level 5, and there's kind of unique definitions of it. The level 5 is, I jokingly just say it this way, like the level 5 is like the K bar that's stuck in your rib of your customer. And the
yeah,
customer is like, they will throw money at you if you can make that pain go away.
yeah,
So what we really focused on during that Techstars work, and that's what we started working with US SOCOM very quickly,
yeah,
was what customer sets have the pain point that we can solve that's like that level 5. I think that was actually a
Yeah,
really
yeah.
good output from that Techstars experience. That was in fall of 24.
But it's like, honestly, it's like everybody. I mean, when you think about, yeah, sure, SOCOM, the military in general. But I mean, we spent some time in the beginning of the show talking about all the different ways that GPS can be denied, distorted, disrupted, and it's like everywhere, and it's potentially all the time. And I meant to say this earlier too, Jesse. When I was writing for Inside GNSS magazine, I was following this Department of Transportation. Basically, they had an RFI, RFP, and they had a bunch of different demonstrations and things like this. But they were calling it, they're on a hunt, I'll call it, for complementary PNT, position navigation
Yep.
timing. Or, in Europe, same. They're calling it alternate PNT. And honestly, I haven't really gone back and looked at it. It's something that the highest levels of government globally are very painfully aware of, and the fact that GPS, it's not just the autonomous vehicles. It's like everything. It's like our
Yep.
financial system. I mean, like,
Yeah.
it's like everything. Medical equipment, even.
Yep.
So when you think about how important this is, and the fact that, now, is it Coleman, or how do you spell this Coleman?
KAL man.
KAL man. Okay. All
Yep.
right. Gotcha. All right. How you've, kind of tapped into that, and then figure, with a software to be able to kind of synthesize or synthetically produce an environment that can then be integrated into all different kinds of systems, I think is just really super cool. By the way, everybody, we did an article on Autonomy Global about Victus early this year. Really, it was one of the first articles of the year, talking about how they've just came out of stealth mode. It's, really quick turn, 2 years, less than 2 years, really. And so we'll drop that link, check that out. But that really got a lot of attention, that particular article. So that message and this message today, like, what's the key message you're trying to get across to people?
The key message, because I think you're right, especially now in the year 2026, the acknowledgement of the problem, like of
Yeah,
GPS reliance or using autonomy in contested environments, I think that's pretty well understood. There is what I think has happened to kind of confuse it is there's still the PNT kind of community or alt PNT community. They've done
yeah,
these people have been admiring this problem for 20 years in some ways, if not longer than that.
yes,
And they do these kind of, frankly, kind of goofy conferences in DC where people fly in and they wouldn't leave with any solutions. And most of the time, the answer was literally, well, just put another GPS antenna up on the device and we'll sell that to the government. That'll make our revenue better. And it will marginally increase the ability to receive a signal. So marginal it
mm-hmm,
has no real effect on anything, but they could say in
mm-hmm,
a lab paper that the effective decibels received went up this very incremental amount. In the real world, it really had no impact, and that was the the whole PNC community. They just weren't interested in this. And then you still have a host of companies and other folks that are, the way I say it is like their business model is based off of, hey, buy this magic box. This
yeah,
magic box will solve your problem. This
yeah,
quantum IMU, this magnometer, this laser com kit, I'll throw in the name of it, this special atomic clock. It will be great. We have there's one drone company we're working with kind of at early stages right now. And they are trying to get the price of drones down, which is a good mission, right? We need
well,
more of
yeah,
them.
that's a huge
Yeah.
issue
It's
right
a huge
now.
problem,
Yeah.
right?
Mhm.
Yeah. So they've gotten this one down, I think, they're trying to get down to $2,000 landed and maybe even
Wow.
like below 1,000. So they're making some progress on this,
Yeah,
just stripping it down and trying to simplify the supply chain, all the stuff that kind of goes into this. So they're working on this, and then they have a requirement to operate in contested environment. Well, they don't have the technology to do this. None of the
yeah,
OEMs do. So
yeah,
then they go shopping and they do, what you'd call like an analysis of alternatives. Well, who can I buy to do this? So they
yeah,
go to a special INS making company that makes this, inertial navigation system, a quantum one, whatever that means.
yeah, Yeah.
And they make a quantum IMU, and that quantum IMU company that can make max like hundreds of this per year. That's it.
Okay.
That's their production. Making one of these particular quantum IMUs, it's about as complicated as making a nano chip. Like you're in temperature, dust controlled facilities, very complicated, very expensive.
Okay.
They quote them $80,000 per drone on their $2,000 drone.
What?
That's the stat. That is the status of what the drone OEMs and other robotic systems, unmanned surface vessels, all the way up to low Earth orbit. That's what they're having to deal with. There's no good options for them.
Yeah.
And part of what we built was we invented a new technology, but we also built a company from the ground up that can be profitable with just software.
Yeah.
I don't have to sell some kind of a hardware
You
initiative. I
don't
don't
need
have
the
to
box. You
sell
don't
somebody.
need the
Yeah,
box. Yeah. Yeah.
exactly.
So on that note, if there's people out there obviously watching this who have expressed interest. How do they tap into your software? In other words, is this software as a service? Is this, you buy a subscription? Is this you just buy it whole cloth and then you have to get updates? Or like what's your business model in terms of like, from a customer standpoint?
Yeah.
How does the customer
So step one is we perform what I call an integration as a service. So
Mhm.
that's where, we try to make this very low friction for
Yeah,
another company or government entity, where they can
yeah,
basically, metaphysically drop this thing in my lap, whatever
yeah,
size it is, and say, I need it to work.
yeah,
Then we take our Docker containerized technology and we then integrate it into that software hardware solution. And that's kind of a variable thing, right? If they're using very open source common standards, that's pretty fast. If they're
yeah,
using a bespoke DARPA project, that might take a little longer.
yeah,
So it ranges in there, but it's something we do. So we do that.
yeah,
There's a whole process we go through for the synthetic environment, the modeling of the agent, the bench testing for the software development, the identification of the sim to real gap, closing that gap for the noise, remodeling that noise, and then integrating for final operational, validation. So it's kind of a whole
yeah.
flow we do, and that's what we do, right? It's an integration as a service. And then after that, it's a simple software as a service, like
Ah,
any other software, like per device, orders of magnitude cheaper than any other attempt for GPS denied solution. And then what you're getting, because it's software that's fully self-contained, you don't have the limits of, oh, it doesn't work if in certain areas without clear defined magnetic lines, or oh, it
mhm.
doesn't work over water, which is how
Yeah,
most right now, or oh, it doesn't work in the dust, or oh, it makes your price go from $2,000 to $82,000 for your landed good.
right.
This is now a very light thing. We also built this ML model, which the synthetic GPS around like the core part of the tech. We built that in a way where it can sit on very cheap compute. So we built it down to a Raspberry Pi 4. This is not a NVIDIA GPU that's powering an LLM factory. Like this is not. This is a cheap chip. I think they're about 65 bucks. That
Mhm.
Raspberry Pi is a company. They originally made these things to just be in grocery stores for price monitors. Like that's all.
Okay.
This is like lightweight compute. So
Yeah,
that also, what that provides is a really optimized solution for somebody who is trying to keep this thing cheap. They're trying to keep it light. They're trying to keep the battery life as high as they possibly can.
yeah,
And and they don't want to, integrate so many things that it becomes so fragile, the whole system just starts to go, its reliability starts to go way down.
yeah.
So that's what we've thought about kind of all these things as we've, what I believe we've done is kind of defined a new category for autonomy, based on starting with the hardest environments first and
Yeah.
then allowing it to generalize from there.
I love that. A new category of autonomy. So what would you call this new category?
Well, I think it's what we're calling it is the contested autonomy environment, because that's where humans live.
Mhm.
Humans live and operate in the real world, which is
Yeah.
not a sanitized lab.
Uh, Very, very true. Very true. All right. This is crazy, Jesse, but we have like 5 minutes left. And I knew our time would fly because you're so passionate about what you've done and what you're doing. It's so obvious that you are, and it's been really a joy speaking with you. But I want to make sure we cover everything that you want to cover in the next 5 minutes before we have to end this show. And by the way, everybody, we'll have other opportunities. Jesse will be at Special Ops Forces Week in Tampa in May. You'll see him. We'll be working together on Autonomy Global Network Live from that event. And then if y'all are going to Exponential this year and Law Tech Connect and you haven't registered, do that. Jesse is on our AI panel, and you can meet him in person at that event as well. So lots of opportunities, and I know you guys are doing a lot more than that. We can get to that at the end. But in the next couple minutes, like, what do you really want to leave people with? And certainly, as part of that, how can people like reach you and learn more?
Yeah, the first one being, if you're making a robotic system that depends on GPS, it has no future in national security. So if you are involved with that, whether it's on the government side procuring it, whether you're building it, and if you're relying on this, there is no future for that. It should use it. It should use it when it's available, like many different things. But if you are relying on it, you have no future. The Drone Dominance Gauntlet 1, Gauntlets 2 through 4, they're gonna start to see this as the government institutes its contested autonomy requirements. It has to be able to operate in these kind of environments. This is where the difference between lab project and science project and like actual real world robotics comes to play. So like that's the first one. Like you have to start with that environment. And then the kind of the second one being is that our whole model is to enable the producers of this to have systems that work in these environments. So, we see ourselves for both our government customers, and we do business directly with the government, as well as with other businesses. We see ourselves as part of the software supply chain. So we've optimized both the technology of business around making your device work where others maybe don't, or where it did not work before.
Or where it was prohibitively expensive.
Or it was exactly. And by definition, then it probably doesn't work. If you think through like if you think the engineering moniker of like swap-C, the C is cost. So
That's
if you blew your cost, it's not interesting anymore. And the future, I think most are in agreement on this. The future of both industrial and national security is characterized by hundreds of thousands of robotic agents doing tasks for us. Orbit, stratosphere, air, maritime, humanoids in your house, ground vehicles, and things all the way down to the bottom of the ocean. And that's going to unlock tremendous national security advantage and tremendous prosperity in the industrial world, from energy to disaster response to a number of things. And mobility, right? The world we want to see is where I can hit a button now and Amazon Prime delivers that thing almost immediately to my front door. That doesn't happen until we're sure that robot can work. So part of what I'm very passionate about is taking robotic systems to the 5 nines reliability. If you think of cloud computing, none of us would trust it with our emails if it was only 80% usable. Like if it only worked 80% of the time. We would all walk around with like terabytes of our own personal emails and plug them into our phone and do this real goofy thing. But as soon as cloud computing goes to 5 nines reliable, like Six Sigma, then we moved everything to it. Robotics is waiting that kind of moment. It's waiting for that. Once it gets to that level, and it will never get to that level with GPS reliance. Getting to that level is what unlocks, literally a whole new generational way of thinking about any of these systems. And that's what we're ensuring that America and the free world has the asymmetric advantage on.
Awesome. Well, man, that was very inspirational. So how can people learn more about VICTUS Technologies? Jesse, how can they get in touch with you? What's next for you guys? We got like 2 seconds left.
Got it. So getvictus.ai is the website. We have our old gen website out now, but has our emails and all contact. We have a very cool website that we're working on right now, which will, I think, be really exciting in about the next 30 to 60 days. You can also find us on the socials, VICTUS Technologies. And then basically, it's very simple. We're, service-based. We care about helping our customers. So you reach out to us on those emails, we get back to you, and we figure out how we can move fast. Startups have one superpower, and that is that we can move fast and we're agile. So we like to go right to the technology, fix problems, and get equipment, these robotic systems, back into the environments we need them to work in.
All right, that is so awesome. All right, everybody, we are at time, and that is all she wrote for today. This is AI and Data Month, and now you know why VICTUS Technologies has chosen to sponsor this particular month and all the amazing things they're doing. Thank you so much, Jesse, for taking this time to be with us here today. And everybody, reach out to Jesse if you have any further questions or inquiries. And otherwise, we are out here.